It hangs in our sky, timeless and familiar, a glowing companion to Earth, waxing and waning through the ages. We've walked on its surface, placed flags in its dust, and left footprints that remain untouched to this day. But there's a part of the moon we've never truly seen, a part that remains hidden in perpetual shadow, where sunlight never reaches and temperatures plunge to hundreds of degrees below zero. In these dark recesses near the moon's poles, ice lies frozen, untouched for billions of years. Preserved in the vacuum of space, it is one of the greatest treasures in the solar system, a relic of the moon's past, a key to its future, and perhaps a bridge to the stars. This is the story of the moon's polar ice. What we know, what we don't, and why this frozen water might hold the key to humanity's return, not just to the moon, but far beyond it. When the Apollo astronauts landed on the moon in the 1960s and 70s, they visited only the equatorial regions, sunlit, relatively flat, and safer for landing. They brought back rocks, dust, and data that would transform our understanding of lunar geology. But they never visited the poles. At the time, we believed the moon was dry, devoid of any form of water, a desolate, airless world of rock and dust. Then, decades later, our satellites began to tell a different story. In the 1990s, NASA's Clementine and Lunar Prospector missions made a startling discovery: strange reflections coming from deep within craters at the moon's south pole. Radar signals were bouncing back in a way that hinted at something unexpected: ice. Frozen water, locked in the shadows, potentially billions of tons of it. Near the moon's poles lie craters so deep and so steep that their floors never see sunlight. These regions are known as permanently shadowed regions, or PSRs, because the moon's axis is tilted just 1.5 degrees. The sunlight near its poles grazes the surface at extremely shallow angles. Mountains can bask in eternal light, while nearby craters remain in constant night. Inside these craters, temperatures can drop to minus 250 degrees Fahrenheit, minus 157 degrees Celsius. At those temperatures, nothing evaporates, not for millions or even billions of years. Scientists now believe that these PSRs act as cosmic freezers, capturing and preserving water ice delivered by ancient comets, asteroids, or even from solar wind interactions with the lunar soil. The moon's polar ice may be as old as the solar system itself, untouched, unaltered, and waiting to be explored. To us, water is life. But in space exploration, water is everything. It's not just something to drink or grow food with. It's a resource, a fuel, a shield. Water can be split into hydrogen and oxygen, the same propellants that fuel rockets. It can be used to make breathable air or to protect astronauts from cosmic radiation. If we can harvest the moon's ice, we won't have to launch every ounce of water from Earth. We could live off the land, build lunar habitats, refuel spacecraft, and eventually leap from the moon to Mars and beyond. In short, the moon's ice could enable a permanent human presence in space. But first, we have to find it, reach it, and understand it. Today, a new generation of missions is preparing to do what Apollo never could: explore the moon's poles. NASA's Viper rover, short for Volatile's Investigating Polar Exploration rover, is set to land near the South Pole. Equipped with a drill and specialized instruments, Viper will search for ice beneath the surface, map its distribution, and determine its depth and purity. Meanwhile, the Indian Chandrayaan-1 and 3 missions, along with other international efforts, have laid groundwork for understanding lunar surface composition, helping pinpoint the most promising regions. Landing in these regions, though, is no small feat. The PSRs are rugged, unpredictable, and cloaked in darkness. Precision navigation is required, and once there, rovers must survive temperatures and conditions harsher than anything on Earth. Still, the reward is worth the risk. The first direct exploration of the moon's ancient water. Why is this ice so important? Not just for resources, but for science. Because it's old, very old. This ice may be a record of the solar system's history, preserved in deep freeze. Within it may lie molecules from the early sun, traces of ancient comets, and possibly even prebiotic compounds, the ingredients for life itself. By studying the moon's polar ice, we can learn about the origin of water in the solar system, the history of impacts, and how volatiles behave in airless environments. It's like uncovering a time capsule buried for billions of years, from an era before Earth even had oceans. And it's right next door. Imagine a lunar base perched on the rim of a polar crater. One side bathed in perpetual sunlight, providing constant solar energy. The other side within reach of shadowed craters, where robots mine ice and deliver it to human explorers. This is not science fiction. NASA's Artemis program, along with international partners, is planning to return humans to the moon, this time to stay. The moon's poles are the prime target, not just for their beauty and mystery, but for their potential to sustain life, to serve as a launch pad for deeper space missions. The moon was once a destination. Now, it may become a gateway. As interest in lunar resources grows, so too does competition. Nations are eyeing the moon's poles, not just for exploration, but for potential commercial and strategic interests. Who will get there first? Who will claim the craters? Who will extract the water? And how will it be shared? The moon, once a symbol of unity during the Apollo era, now faces new questions of ownership, cooperation, and preservation. If we are to use the moon's ice, we must do so wisely, balancing exploration with responsibility. Because once we melt that ancient ice, there's no going back. The moon's poles hold a mystery that could change everything. They remind us that even the places we thought we knew best still have secrets left to share. That even in the silence of space, there are stories frozen in time, waiting to be uncovered. As humanity prepares to return to the moon, we are not just retracing old steps. We are stepping into new light, new shadows, and a new era of exploration. The next giant leap won't be on the dusty plains of the moon's equator, but in the ice-filled darkness of its forgotten craters. And what we find there could light the way to the stars. Long before our machines probed the moon's hidden corners, ancient civilizations looked skyward, wondering what secrets the glowing orb might hold. The moon guided tides, marked seasons, and inspired mythologies. But only in the 20th century did we finally reach it. The Apollo program, extraordinary as it was, only scratched the surface, literally. Yet just beyond its reach were these polar shadows, preserving a treasure we hadn't yet imagined. Radar, infrared, and impact probes helped reveal what the human eye could never see. Through clever detection, we began to map the moon's invisible water pixel by pixel. But now, it's time to see it up close. Viper is just the start. Robots will crawl across the surface. Ice drills will sample the darkness. Future missions will extract and purify. Engineers are now designing in-situ resource utilization systems, turning moon ice into usable water, air, and fuel. We're building the technology of off-Earth survival. Astronauts at Artemis Base Camp will endure harsh cold, high radiation, and long nights. But they will also experience something no human has: working beside ice untouched since the solar system's infancy. Lunar ice is not unique, but it's uniquely accessible. Unlike Europa or Enceladus, it's only 3 days away. A perfect proving ground for deep space survival. As we mine, we must also preserve. These are not just resources, they're records. The moon's ice holds answers to questions we haven't yet asked. Let us explore, but not erase. For 4 billion years, these shadows stood untouched. Now, humanity is finally ready. What we find in the silence may define the next age of exploration. We once looked at the moon with wonder. Now, we return with purpose.